Hello and welcome to another video tutorial for ANSYS Workbench. In this tutorial we're going to focus on a few key learning outcomes. The first one is we are going to use ANSYS to model this truss, and each of these solid black lines here represents a member of the truss, and you can see that they have been numbered 1 through 5. Each one of these truss members has a different cross section. The first member has a 0.1 meter square cross section, and it's made out of aluminum. And then member 2 has a 0.1 meter radius, and it's a solid circular member made out of steel, and so forth. And so what we are going to learn how to do in this tutorial is first generate line elements and then turn those elements into beams and assign cross sections and material properties to each one of those beams. You can see our boundary conditions are that this node down here, or this point, is fixed in both the horizontal X and the vertical Y directions, and this point up here is fixed in the horizontal X direction. These two values over here of 200x and minus 1000y are the magnitudes of a point force that have been placed at the end of this beam. These red numbers shown in parentheses represent the coordinates of the truss, and these coordinates are shown in meters. So let's go ahead and open ANSYS Workbench and begin to develop a model to solve this problem. After opening Workbench, we can come across the top and click on Units and make sure we are in metric units with meters. And so that's set. Then we can come down to Static Structural and either double click on it, and that will bring up an icon in the project schematic window, or we can click on it and drag it. Now, in terms of materials, we have both steel and aluminum that we'll be using in this model. So I'm going to double click on Engineering Data, and by default, steel is loaded there. I can look down and verify any of these properties of steel, and I'm going to go ahead and just use the defaults. Now I want to add aluminum. So I will come over here and click on the top on Engineering Data Sources, which lets me go find other materials. Now, from experience, I know that aluminum is kind of a general material, so I will double click on General Materials to open up the list of general materials that ANSYS has put together, and that is shown up here in the outline of general materials. And now I can scroll up and down this list with my middle mouse roller. I can click on aluminum alloy. I can come down here and see the properties of this particular aluminum alloy, and I can go ahead and click on the plus sign. That puts a little book here, meaning that that has been added, and I now have added aluminum with these material properties to my materials list. I can come back here now and click on Filter Engineering Data and deselect this, and I can see that I have aluminum added. And if I click on aluminum, now I have these properties, and I could go in and click on these values and edit them as desired. So it's pretty easy to add other materials. To get out of this, all I need to do is close this window by clicking on the X, and I'm back to my project schematic window. I'm now ready to add my geometry. As we recall from the first video, we just worked down this list of menu items. We have a green check by our engineering data, question mark by our geometry, meaning there's no geometry added yet. So I will double click on geometry. I can see down here that my green dot changed to a red light, and it says starting space claim. and I know that my computer is busy bringing up space claim, so I'll pause and come back once space claim has come up. So after opening space claim, I like to right click on select new sketch plane, and I like to sketch in the XY plane. So I'll hover over this until I highlight the XY plane, and then I will use that as my sketch plane. I can hit plan view and look at the XY plane straight on. I could have also come down here and hit these icons to get the direction that I want to look at as well. And so you can see I can hit Z, and now this has rotated it, and so if you continue to click Z, it will rotate that back to a conventional XY coordinate. I can now hit Control middle mouse button and move this to the center of my window. Now I want to check my units, so I come to File, Space Claim Options, and click on Units, and I can see that I'm metric units and the length is meters. I actually want to do this model in meters, but if you wanted to use millimeters or have the dimensions show up in millimeters or centimeters, you can pick those dimensions there. Then another one that is also commonly used is to change the dimensions and the precision by setting the trailing zeros. And here you can determine how many zeros you want to have follow your decimal point. And then down here, I also like to adjust the minor grid spacing. 0.1 meters is what I usually like to deal with if I'm doing everything else in meters. And so I'll leave that as 0.1, but that's usually not the default. So now I have everything set. I can go ahead and click OK there. And I'm in sketch mode. I can see that this is sketch mode here. I can see that I have my sketching tools and I'm ready to begin to draw. So I can click on the line and I'll start at the origin, 0, 0, and I'll left click and drag a line vertical. And while holding down the left mouse button, I will type in 3, enter, and that will make that vertical line 3 meters long. Now I can just leave my cursor there and left click and drag my line over here, and I can type in 4, enter, and that'll make that line 4 meters long. So I now have two members of my truss built. If I come here and click this member and roll down here, I can see that this other member is going to be a little tricky to put in because I don't know the angle in radians and I don't know the length of that line. What I do know are the Cartesian coordinates. So I'm going to go ahead and while continuing to hold down the left mouse button, I'm going to hit escape, and then I can come over and click on the options sketch and scroll down here and click on Cartesian dimensions. Now when I come up here and click on this point and drag my line, I have Cartesian coordinates to help me find where I want that line to be. And that will actually go down 2 meters and left 1 meter, and that will create that line. Now I can click that point and come to my origin, and I have one more line to click. So I can come up here and click escape so that I don't create it from this point, and then I can click this point and bring it over to this point and let it go. And I have now created all the members of my truss. I can go ahead and hit escape, and that brings me to where I can draw a line. If I hit escape again, now I'm back to a neutral position. I can hit Control middle mouse button and drag my drawing to the center of my window. So now that my geometry is created, I'm ready to start to add my cross sections. But before I do that, I typically like to just do a gut check to make sure my model consists of the parts that I think it does. So coming over here under my structure tree, I click on this arrow to open up the drop down, and then I see that I have one sketch in my model, which makes sense, and then I open that and I can see that that one sketch consists of 5 lines, and those are the 5 lines that are over here, and so those all make sense. If I deselect that, I can cut it out of the model and it doesn't show up in the picture. Often that's easy and a nice way to hide things so that you can see other geometries and continue to draw when you have a more complicated model. So now I'm ready to go ahead and start to create my cross sections. So I'll come across the top here to prepare and click on prepare, and then I go to profiles, and this opens up a drop down window. Now these new profile library members here are geometries that ANSYS has already developed. We also can look up a standard library where we can look at the American Institute of Steel Construction code that has all manufactured beams and the properties for them, and we have the Eurocode where we can look up European beam standards and use those. We can also go in and create our own cross sections for our own beams that may not be standard and develop them in a CAD model and then read them in as well. But for this model, we'll be able to use the profile library given by ANSYS. My first member, if you recall, was a square aluminum member, and it was solid square, so I'll click on solid. You can see here that it has beam profiles, and now what I need to do is click on create. And if I come over and open up my beam profiles, I can see that it created a rectangle. If I want to change the name of that, I can simply double click that window and highlight it, and I can type in rectangle or RECT1. And now I know that that is my first beam. And then click on my structure and I can see that that rectangle has been loaded. The next thing I need to do is add a solid steel circular member. So I'll click on solid steel and click create. And I won't go look at that one, but I can see it's been created there. I need to have another solid steel circular member that's got a different radius, so I'll click on that again. And this is where I could go change those names if I needed to help me understand the part that was being made. Then I have a hollow circular tube, so I'll come here, click the drop down, and click on the tube and hit create, and I've created a circular tube. And my last one is a square member, a hollow square member. So I'll click on the hollow square and click create. And now I can see that all of those have been created, and I can go modify those for the specific dimensions in my particular beam. So if I double click on rectangle 1, I can see here that it has brought up this definition and shows me that I don't have an area, I don't have a centroid, no IX, IY. And so what I need to do is enter those properties, and the way to do that is to come to rectangle 1 and right click and then click edit beam profile. And that brings up this window here where it shows us our square cross section, and we can come and change the base and height of this member. So I'll click on the base, and it tells me right now that by default it's 0.01. I need to change this to a 0.1 meter base. So I'll type in 0.1, enter, and I can then click on that again and see that that has made that change. Click on the H, click on the 0.01, brings up the window for me to type in 0.1 and enter, and I now have that dimension. I can come over here and use my middle mouse button to scroll in and scroll out. And I have now changed that first cross section to be 0.1 meters square. Now you can see that in this bottom row I am now in groups, and I want to look at my structure tree and go to the next cross section. So I'm going to come back and click on structure, and that will bring me to my rectangular structure tree. And this shows me the structure tree for this particular cross section. If I want to see the structure tree for the whole system, then I need to come down here and click on System and go back to the overall structure tree for the system. I can come to Beam Profiles, then I can right click on Circle, edit Beam Profile, and now I can come in and edit the radius of this. And we wanted the radius here to be 0.1 meters, so I'll click on it. Then I'll click on the 0.01 and type in 0.1, enter, and I've now changed the radius of that, and you can see that it created another system down here. So if I want to go back to my original structure tree, I go back to the first one, and I can look at Structure and Beam Profiles, and then I'm ready to look at my second solid circle, so I'll right click on that, edit Beam Profile, and this one's a 0.05 meter radius, so I'll click on here and then click 0.05, enter, and I can then jump back to System, jump back to Structure, open Beam Profiles, and I can come to my circular tube and right click and edit Beam Profile, and now here I enter in the inside radius and the outside radius, and my inside diameter was 0.1, so my inside radius will be 0.05 and my outside radius will be 0.06. I can hit enter there. And the last one I have to enter now is my hollow tube. So I'll come down here, back to System, back to Structure, back to Beam Profiles, right click Rectangular Tube, click on Edit Beam Profile, and now we have a lot more information to enter in this beam because there's more dimensions. But for W1, I will enter, it's a 1.2 outside square. So if I look at what the dimension of W1 is, it's this full dimension down here, so that will be 0.12. I can click on that and type in 0.12. W2 is the same, and so I can click on that dimension, click on the blue line, and type in 0.12, enter. And now I'm ready to enter in the thickness for each member, and the thickness will be 0.01. So I can come to T1, click on it, and the default is 0.01, so that's already set, and I should not need to change these others, but I'll check them just to make sure that those are the values that were given. And now I have all my cross sections built. I can come back to my system, go to the structure tree, open my beam profiles, and I can look at each one of these, and now I can see areas that are given. I can see some other properties of them that are shown down here in my beam section. Now, it doesn't give me an IX and an IY until I've actually created these, and then I can come back and see what those values will be. To assign the cross sections to the beam, what we want to do is come and click on Prepare, and then underneath Prepare we can see that it comes up, and my first item here is my rectangle, and that was line number 1. So I can click on that and then come over here and click on this line, and that has just made that line rectangle 1. And if I come over here and look at my beams, I can see that I've got one beam and it has the rectangular 1 geometry. Now I can come, and my beam 2 was the 0.1 meter radius solid circle. That was his first one, so I can click on that, and now I can come and click on beam 2. I can come up to the drop down, click on 3, where 3 was the solid 0.5, circle 2, so I can click on that and then click this beam member. And you can see that as I click those, I'm generating these beams over here as well. So I have beam 4, which is the circular cross section with the hollow tube. So I'll click on circular tube, come down and click on this element. And now my last one is this rectangular tube, and it's this member over here. And so now I have all my beams created with the appropriate cross sections, and I'm ready to move on. Now what I want to do is move all of these to a new component so that I can combine them together and essentially have one solid truss where everything's connected instead of a bunch of individual beams. So what I will do is I'll come along the top and click on Design, and then I'll click on Select, and then I can click the top beam and shift click, left click the bottom beam. So I've selected all of those, and then right click and click on Move to New Component. And I can see I have a new component up there. I can leave it as component 1, or I could name it something. I'll just leave it as component 1. Now I can click on beams, and I can open it up, and I can see that I have all of those beams there. And now what I can do is when I click on component 1, I can come down here to the share topology, and right now they're not sharing any, but if I click on this drop down window, I can say merge, and it will treat them all now as a merged topology, and so all the beams are essentially welded and connected together. One other thing that's worth showing is if we go back to prepare and click on prepare, then we can come to display and we can look at solid beams, and this gives you a little bit of an idea as to what your model looks like, and you can check to make sure you've got the beams in the right place. You can see we have a large circular beam in the middle, and then our top one is rectangular for sure. You don't get a great picture, but you can kind of get an idea that you have the right geometry. So with this, we're ready to open ANSYS Mechanical. I typically like to save this file at this time, so you can go to File and then Save As, and you can save it as whatever truss name you'd like to save it as, and save it where you would like to save it. This is going to a local temporary directory, and I probably want to save it somewhere else. For this video, I won't save it. So I can minimize this window. I often don't cancel it and close it, but I just minimize it. And you can see that we have a green check by our geometry. We're ready to go into ANSYS Mechanical, and so I'll double click on Model. I can see down here that I'm starting mechanical. I have the red light, meaning it's thinking. And once it comes up, we'll start to do our mechanical modeling. So when mechanical comes up, you can see that it's really hard to see your truss, and that your truss is oriented at kind of a strange angle. The coordinate system and the angles are based on this isotropic view down here. If you want to change that, you can look at it more this way, but it's still really hard to kind of see the lines in there. So it's good to get this meshed and get a little thicker line there that we can see. Again, in mechanical, we want to start at the top and work down this menu. We can see that our geometry has imported just fine. We have a geometry import. We've got a green check there. My geometry now for details consists of component 1. If I open component 1, I can see that I have a rectangular tube, a circle, circle 2, and a circular tube. And as I look at this, I go, hey, I have 5 members in this truss. One of them is missing. So what's missing? And if I look here, I can see all 5 members of my truss. So that appears to have gone through just fine. So I can come back down and click on my space claim window. And if I look at my space claim, I can say, oh, I have 2 beams that are labeled as rectangular tube, where one of them should be labeled as rectangular, or as rect 1. So I will go ahead and click on this, and then come down here and click on the rectangular tube and change this to rectangle 1. And now I can save that file again. I can come back to my mechanical window, and I can come here to geometry and right click, and then click on update geometry from source. And it'll go back and read the data from the file, from the space claim file, and you can see now that it has made this beam rectangle 1 in there, but it has a question mark by it. So if I click on that, I can see that it does not have a material assignment. And so when I made that change, it did not assign a material to it by default. So this first rectangle was aluminum, so I'm going to come down here to this material assignment and click aluminum alloy. Now while I change that one, I can go ahead and check the material properties of all the other ones. So my first circle was steel, so I can come down here and see that it's structural steel. My second circle was steel as well, and I can see that it's structural steel. And then my tube, my circular tube, was made out of structural steel, and I'm good on that one. But my square rectangular tube up here was made out of aluminum. So I need to click on the rectangular tube and then click on that drop down and change that to aluminum. So now I have all my materials in there that are right. I have my geometry in there that's correct. I can click on my materials and see that I have these two. If I click on aluminum alloy, I can see the properties of it and remind myself of what the values I have entered in are. Do the same thing for structural steel. I can click on my cross sections and I can see that I have my 5 different cross sections in there. And I can click on those and look at the individual details as well. I've only got one coordinate system, so I don't need to do much with that. I can click on connections and it just shows me a blank screen because everything has been connected as one component and I don't have to connect anything. So in this tree, everything's looking good and I'm ready to look at meshing. So if I click on mesh, it will bring up the meshing menu here, and I can go ahead and just click generate, and it will generate a mesh, and I can see the mesh that has been generated. I can get the details on this worksheet down here. I can middle mouse button this and roll it around, and I can see a solid tube and a hollow tube and my circular tubes, and everything seems to look pretty good there in terms of a mesh. Now beam elements have quite a bit of resolving power, and so you don't need a lot of beam elements to get an accurate model. So I'm not going to refine this mesh. We'll go ahead and leave it with this geometry or with this mesh size. We're now ready to apply the boundary conditions and the loads. So if you remember from the first figure, the boundary conditions were displacements in the X and Y directions down on this node and displacement in the X direction on this node. So coming under static structural, I'll come up here to displacement and I can pick this node or this element or whatever I want to apply my boundary conditions to. In this case, I can see that it's given me a displacement. It says geometry, geometry selection, and so when I click on something here, it's looking for a geometry component. If I want to apply these boundary conditions to a node or a vertex, then what I can do is click along here and click on different items that will be selected by the cursor. So there's a difference between a vertex. A vertex is a geometry component, where over here a node is a nodal component and part of the mesh. For this model, we'll go ahead and just pick the vertex and apply the boundary conditions to the vertex. So I'll click on that vertex, and then coming over here, I'm going to set the X component to 0, the Y component to 0, And I'm going to go ahead and set the Z component to 0 as well. And now that boundary condition has been applied at that vertex. It still hasn't selected a geometry, so I'll go ahead and, since that that vertex has been selected, I'll click apply. And now it has one vertex, and it tells me that I have a displacement boundary condition there, and the components of that displacement are 0, 0, and 0. So no displacement in the X, Y, and Z directions at this node, or that vertex. Now I can come up and click this vertex, and I can click add a displacement boundary condition again. Then I can come down here and click on vertex and click apply. And right now it's free, free, free. I'll go ahead and set this as displacement in the X as 0, and I'll leave the other two displacements as free. So now I can see that displacement 1 here is set for 0, 0, 0 at that vertex. Displacement 2 is set for that. I can see that I have green check marks here. I could go add other boundary conditions as needed, but these are the ones that I'll go with and see what I get for a result. Now I'm ready to add my force, so I'll come up here and I can click on force, and I'll come over and click this vertex, and I'll click apply, and I can see that it has the one vertex selected. Now, instead of defining this as a vector, I'll click on vector and define it as components, and I can enter in an X component of positive 200, and I can enter in a Y component as minus 1000, and no Z component. And so I can see that my force has shown up over here. There's the magnitude of the force, and there are the components of the force. So I have my displacements, my boundary conditions, and I have my load. I'm ready to ask ANSYS or tell ANSYS what I want it to solve for. So I'll click on solution, and we'll often look at the deformation. The deformation is good to look at because it's kind of a gut feel that the deformation looks right. If it looks right, then it gives us a warm fuzzy that our modeling might be along the right lines. It certainly doesn't guarantee that it's right, but it helps us with an understanding. Then when we look at stress, we can see that there's no ability to look at stresses here, and that's because we have beams. And so what we want to do is come over here to Toolbox and use a beam tool. And then when I come over here to beam tool, I can see that it gives me direct stress, minimum combined stress, and maximum combined stress. And so that's pretty helpful. I can also use this beam results diagram and look at a shear moment diagram, for example, of these beams, if it was set up for that. I can look at the bending moment and other things as well, based on what I type in here. And so now I have a lot of yellow lightning bolts, meaning this thing's ready to be solved. I have a lot of green check marks, meaning I've entered in a lot of information, and I'm ready to come up and hit the solve. So I'll click on solve, and then I can see down here that ANSYS is running. It's 10% building the mathematical model and proceeding through the solution. Now when my solution came back, I see that I get a bunch of red lightning bolts, bad signs. And I come down here and I look along my bottom, and I can see that I had two messages. So I can click on those messages, and it says a solver pivot warning or error has been detected in the ROTX degree of freedom. So I can click on that, and I can open that message up by double clicking on it, and it says a small pivot warning error detected in the rotation X. So what this means is my model is rotating about this x-axis and it's unconstrained. And if you remember, what we did is we put a single restriction up here in the x direction so this thing couldn't translate in x. Down here, we only pinned this connection. So this is like a ball joint, and this truss can freely rotate about the x-axis about this point. And so we didn't recognize this early on, but now we see based on this error that, hey, my model is not constrained from rotating in the x direction. So I've got to go back and fix that. So I'll go ahead and click OK here. And now I will come back to displacement 2. And instead of leaving the y component and the z component as free, I'm going to go ahead and set those displacements to zeros. And now this essentially makes it a simply supported beam. I could have also come down here and made this a clamp beam and fixed the ends. Lots of ways we could do this, and you would want to look at your actual model to see what makes the most sense. But now that I have changed that, I'm going to go ahead and click on Solve again and let it go off and solve. Now when I thought I had my boundary conditions all right, I get red lightning bolts again. And I come down here and read the error, and it says a solver error has been detected, rotation Y. And I think, how can this thing rotate about Y? And what I have done is I've pinned this node and I've pinned this node, but there's nothing that's keeping this thing from swinging about the y-axis. And so if there's any just minuscule force in the y-axis, it's going to cause this truss to rotate and spin about that y-axis, and ANSYS can't solve that. So what I need to do is I need to fix one of these nodes out here in the z direction so that this truss can't spin about the y-axis. Or again, like I mentioned, we could come down and use a fixed support and make this a cantilever beam down here. Let's go ahead and just add a displacement boundary condition in the z direction out at this point. So I can click the vertex, I can come back to static structural, under which where I apply my boundary conditions, and then I'll click on displacement, and this is displacement 3, so I'll go to displacement 3, I will select that vertex, and now I'll fix the z direction to be 0 and hit enter. And now I can see that I have 3 displacement boundary conditions and my force and a bunch of red arrows. So let's see what happens now when I hit the solve. So you can see it solved really quick, and I have a bunch of green arrows. So sometimes we get frustrated thinking, hey, ANSYS is not working right, ANSYS is telling me this and I've got my model right, but ANSYS is understanding the model, and we need to make sure that the model's doing exactly what we think it is. And so when you get that small pivot error, it's usually because your model is unconstrained. We can come and look at the axial force in the members, we can look at the total bending moment, the total deformation. It makes sense out here that this member's deformed the most. It was where the load was applied. We can also come down and look at these beam components and the direct stresses and so forth. So hopefully this 2D truss example has been helpful to you, and we'll see you at the next video.